like
they were not even in engineering.
Probably some marketing guy. Okay, so we are officially doing this from the kitchen because I can't find any other quiet spot in my office, so that's happening. What else is happening? To give you an idea of how this presentation is going to go, at about 1:30 a.m. last night, I had a completely different idea. I dropped like 10 slides and I changed it all. So this is going to be a thing. I was talking to my girlfriend about it, and I'm like, should I make this more entertaining? Should I just like do the whole thing in the voice of like Daniel Radcliffe or something? And she was like, that's not, don't do that. So
that's very specific.
Do that. Come on.
The whole impression is just sort of like being incredibly nervous for like the entire time. Just, oh God, I made this Elm thing, but I'm so frustrated, and I'm just really happy to be here, and I'm sorry guys, I'm really sorry.
You should do this Voldemort.
Oh no, why is he here? This is terrible. Yeah, we're not gonna do that though. Hi everybody, welcome. Thank you all for coming. This is my Elm talk. We have like a pretty good crowd here. I think it's all folks I know, which is great. I'm super nervous about this, but you know, bear with me.
We got you.
Thanks. We're gonna see if we can kind of make this a thing. Ever since Brian wore the suit for the first one, I've just been like, I gotta step my game up.
I had to set the pace.
Tuxedo t-shirt.
Missed opportunities. Okay, so if we're all set and ready to go, I think we can jump into this. I'm gonna try and do the screen share thing, and let's hope that doesn't screw up. Let's see, and I'm gonna do a quick check. You gotta do the quick check on Zoom and make sure that like none of your tabs or whatever will embarrass you, because that's how life works. Okay. And I'm gonna keep making awkward noises until everything is fine.
Do a cooking show. You're in the kitchen.
No, like the Mountain Dew brine.
Yeah.
I refuse to even address that.
Gotta get with it. And oh, everyone see that?
Yeah.
Okay. Cool, because you're about to unsee it. There we go. Okay, so hey everybody, welcome to my Elm talk. Oh, I think I'm gonna slide ahead, but that's okay. There we go. Introduction to Elm. Boom, there we go. After sort of seeing the first brown bag, I really wanted to share something with the community, and I was like, well, what can I share? What am I good at? And then that got sad real quick. And I was like, hey, you know, I'm really into this thing called Elm, and I think it's the type of thing that might be interesting for you guys. I know a lot of the virtual coffee people are in the web development space, and especially like a functional programming is the type of thing that like everybody always kind of has an interest in, but it's like finding the time to learn about this thing. Like we're always in that loop of everything is interesting, but like when do I have the time to learn about this thing? And I like brown bags because somebody can take the burden of like making the time to learn about it for you, and you just have to sort of follow along. So I really like this, and we're gonna give this a try. Okay, so what are we gonna talk about? Framing is important. How did I find Elm? Like Elm is still relatively small, maybe about like, I don't know, a few thousand repos on GitHub, and you know, it's a relatively new type of thing. So it's like, how did I even come upon it, even though I don't actually do web development? So we're gonna do that. What actually is Elm? Why is it named after a tree? I don't know why it's named after a tree. and just a sort of a quick overview of what functional programming is for those who are unfamiliar, and you know, we're going to get into that. Why you should try it, you know, that's always fun. Ultimately, I think like my goal is to just expose you all to a tool that you could use, and if people are interested, for the month of for Hacktoberfest, I'm going to be working on an open source Elm project. Everyone is welcome to come on it. I will post a message in the Slack, but if anyone wants, I will be doing like at least an hour where we pair up and I walk you through like getting into the language, like doing your first set of things. So that's going to be cool. Yeah. And then if time permits, we're gonna do some demos, some live stuff, because I went through like a million variations of this presentation, and each time I iterated, I just cut out less and less slides. I'm like, let's just do it live. We're doing it live. That's a Bill O'Reilly reference, and no one will get. Cool. What we are not going to talk about, that's pretty important. Why Elm is better than anything else. That is the bad place, folks. We're very passionate about the things we do. We're very passionate about the things that we like, but ultimately all these languages, all these frameworks, they're just tools. And I feel like whenever you get to the point where you start liking your tools so much that you start like poo-pooing other things, then, you know, if I start doing that, I become a tool. So we're not gonna do that. We're just going to expose it. So I will tell you the advantages of Elm, or what I think are the advantages over like other methods of programming. But this is not a drop what you're doing and jump to Elm. This is a, hey, this is something else that gives you these types of benefits. High level functional programming concepts, the math place. We are not really going to get into that. There's an image there of like some of the actual category theory type stuff that people love to talk about, but we won't. For a long time, people thought that to learn functional programming, you have to learn this stuff first, which to me always sounded like, well, you need to get an auto mechanic degree to drive a car. Like that's not really how real life works. And I genuinely think that it held back usage of functional programming for quite a long time. A lot of people think like FB is new. Like we've had functional programming since the 50s, like since like object-oriented stuff. You know, it's just, people were like, oh, you just have to learn, you know, higher level mathematics before you can try it. And one of the things that Elm flipped on its head was said, hey, let's not do that. Let's not mention any of this stuff at all. Let's just show people how to code. And then if they're interested, they can find out more later, which seemed way more sensible to me. And yeah. Last thing, testing, tooling. There's some really cool things that are sort of built on top of Elm, you know, and I wish I had the time to go through all of them. They're really amazing. Like some things, it's like Elm is just like a convenient way to use some of these frameworks, but we don't have the time, so I'm just going to try and keep it simple. Yeah. And I guess to sort of start it all off, ultimately, when we're learning about any language, what matters most is not syntax, but semantics, meaning. It's not the individual symbols or structures, but the patterns of thought that the language enables. In the end, people choose the tools that empower them. So I suppose my brown bag today is about how Elm empowers me. Yeah. Cool. Okay, how did I find Elm? JavaScript is a lot. I tried several times to learn web development. It did not take. JavaScript confuses me, the ecosystem confused me, and I would get stuck in tutorials and I would burn out. And I mean, those of you in the web development space know that like one of the issues is if you take a break for like 2 years and you come back, it's just like there's a new thing. I remember when I first went into it, like jQuery was the thing. I'm like, okay, cool, jQuery. And then I got a little bit, then I stopped when I came back and was like, hey, dude, you do Node? I'm like, what the hell is Node? Node, man, everybody's on, you know. And then I came back again. It's like, oh, Angular's the thing. Everything's about Angular. We're Angular now. We're Angular people. And then, you know, it's like, React. React is now the new thing. And now it's like, it's not even just React. It's like, oh, what flavor of React? What flavor? Like, is this ice cream? Like, what are we doing? It's like, well, it's React Native or React or Preact. Or... So, you know, that always held me back from getting into web development, because I never felt like I knew how to make something real. Like, I always like wanted to know, okay, what are actual web developers doing? Can I just do that? And like every time that would change. And that bothered and frustrated me. So I really just figured I would never get into web development. And then at the point of giving up, you know, I'm working as like a desktop app developer of Python, doing a lot of that. I found out about functional programming in a way that, you know, I'm always a hipster about things. So like, hey, you know, there's this other type of programming that not a lot of people do. I'm like, oh, okay, so you're saying I should do that. And I got really into it with Haskell, but it was a similar situation with JavaScript where like I would do Haskell tutorials and I just like, okay, great. I know how to, you know, make a length function from scratch. I still can't do anything useful. I got I got frustrated with that too. And, you know, you get to a certain point where you're like, is this just me? Am I just like terrible at this? And then somehow, you know, in that space of looking at functional programming and also working on Python, but still kind of like not wanting to give up on web development, I discovered Elm. And that kind of changed everything, both on the functional programming end in terms of like writing real code, and then on the web development end of like making real web apps. So that's cool. I'm gonna take a brief pause here just to make sure, just to kind of jump back into everybody. I know I forgot to say this at the start of the application. While I'm doing this, I can't really see the chat. So if you do have questions, feel free to unmute, jump in, just point it out, and that'll be cool. Is everyone with me so far? Cool. Okay, so we were at the point where I'm very confused and frustrated, and I don't know what's going on. So programming. All right, let's dive back in. Okay. Look, why is it named after a tree? I really don't know why it's named after a tree. Oh, well, there we go. So Elm is a purely functional programming language for creating browser-based GUIs created by this guy, Evan Sublippi, in 2012. Look at that picture. Isn't he wonderful? This was before like it made it on Hacker News, so he was still happy, you know? Evan wrote Elm as part of his master's thesis, actually looking into stateless UIs. So the typical system we tend to use for user interfaces is sort of like object-oriented, event-based systems, right? There's some sort of actor at the front of the application that has a particular state. When that state changes, it tells a controller, hey, my state changed. Your state changed. Oh my God. And then the controller does whatever database the state changed. What, you know? Functional programming doesn't have the concept of classes. It doesn't have the concept of entities that have both like state and methods. You know, you're either a data or you're a function. And there's a lot of advantages that come with that. And Evan was like, okay, how can I make something that does this? But he was also trying to address a need of himself when he got into web development, where he was like, there's certain things that I'm just not sure if they work or not. And a lot of web development is like, well, you write the code and then you sort of like hope the thing that comes out on the other end is what you want. And that sort of uncertainty is frustrating for a developer, because the whole point is that we're trying to figure out logic so that the program does what we want it to do. So he made this thing called Elm, and ultimately, and I think this is sort of like the main thing to keep in mind, Elm is just, Elm just compiles to JavaScript in the end. So it's one of those languages, it's just completely, when you compile it, completely goes to JavaScript. PureScript does a similar thing, I guess. I'm not sure if TypeScript works the same way. I'm pretty sure like TypeScript, like they all just compile to JavaScript. So Elm programs like React render HTML in Virtual DOM, and then it talks to other parts of your application through JSON. For those who are not sort of like in the web development space, the DOM, which I think is the document object model, is just like how your browser basically tracks all the elements that you're trying to render. And what Elm and React do is, instead of messing with that directly, which can be kind of an intensive process, they make a virtual representation. Everything's done there first, and then they just try and get the two to sync up. So it's a lot faster, it's more lightweight, it's safer, blah, blah, blah. And you know, that's the basics of what Elm is. So I'm gonna ask you what Elm is. Elm is a functional language. It compiles to JavaScript. It runs, and then that runs in the browser. Elm is front end only, and that's like a really important thing. It's a full language, but like Elm is specifically designed to make front end code and like front end UIs. And there's a lot of clamor from the community sometimes about like, well, when is it going to be server side? You know, like when is it going to be? And Evan's response has always been like, well, his priority is making the best possible experience on the front end. There's lots of great things that work on the back end, and you know, he actively encourages people to use the things that they like for that. Like, that's not the problem that Elm is trying to solve. So, you know, if you're thinking of getting into it, you know, just so you know the space that you're going to be applying it in. Cool. And I guess the main thing we're going to talk about today, and we're going to see a lot of, is Elm's most well-known claim to fame, which is the Elm model of web development, this thing called the MVU model, or the Elm model, or you know, the React Redux model. And it's this idea of your model is the state of your application. You know, it's the only thing that has state in your application. It's the one source of truth. Everything in your application ultimately comes from one central model that you define. Your views are just functions. They're not objects. Views don't have any state of their own. All the view does is it takes the model as a parameter and it spits out HTML and messages. And messages are just the ways of defining how your application can actually change. So your model is your state, your view makes your HTML, and messages are how you want the application to change. And the update function is really where the magic happens. The update function can take a message and it can update the model. That's the only way to update the model. That's the only thing in the application that actually changes as time progresses. And everything else is stateless. Everything else is pure. And that's sort of like how Elm works. Is at this point where I had like about 40 other slides and we were going to walk through a bunch of different things. But how about we just don't do that and we just actually watch some Elm code? I think that could be kind of cool. I just need to figure out how to do that.
Elm it up.
Yeah. I'm probably going to break the screen share again. So just be aware of that. Oh, okay. Are you still here? It's still here? Hey, cool. And now that I'm not in like super play mode, I can actually see your faces and check if everyone's asleep or not. Uh-oh. Okay, so where are we going now? We're gonna do a new share. Love that. And we're gonna jump to Google Chrome. Yeah, Google Chrome. Cool. And let's see if I can hide the video panel. No, hide the meeting controls. There we go. All right, folks. So we're gonna jump to here. Can everybody see that? Great stuff. Okay. So this is eliapp.com. It's a way of writing Elm in the browser, which Elm is a framework that makes code for the browser. So that's nice and meta. And this is sort of like the most basic Elm thing that you can do. So we're just going to kind of walk through this. So the first thing I kind of want you to notice is that there's two files here. One is the Elm file that you will be writing in and all your code goes in. And The other file is a regular HTML file. And you can see this little script here. At the end of the day, it's just like any other JavaScript thing. Like you're just gonna call this little app called elm.main init, and then that's all that goes on. So when you compile an Elm app, you will have your original Elm file. It will make a JS file, and you can stick that in your HTML. So like, it's your option if you want to do your entire web app out of Elm, or you can do a tiny piece of it out of Elm and just like attach it to the rest. And most people introduce it to their code bases by, they already have an existing JavaScript app. Okay, I'm going to just do this little piece in Elm. And eventually that takes over their whole code base. And eventually they start going to conferences, and eventually they start like growing out their beards. Like it's a whole thing. But it's fine. You know, but just to say like, let's not like have any particular mysticism about it. Like it's just, you know, any other thing. At the top, you sort of always like define your module and what your module is exposing. So this is the main module exposing main, cool. HTML library, cool. And now let's talk about this right here. So all Elm apps start with a main function. That main function can produce 3 types of values, either HTML, SVG, or something called a program, which we're going to jump into a little later. We're also not going to mess with SVG today because I don't need to do math in front of other people. But the first thing I kind of want to go over is just like the basic tenets of functional programming for those who haven't been exposed to it before. There's a lot of definitions out there, but I will say sort of like 3 things matter. 1, in functional programming, all values are immutable, which means you can only declare something once. So if I try to do x equals 3 and then x equals 5, we're going to hit compile and it's going to yell, hey, this file has multiple x declarations. Dummy, x equals 3 and x equals 5. How can I know which one you want? You can't, once you said what something is, you cannot do it again. So, you know, you can say like everything's a constant, or you can just say like objects can't change. And some people use the phrase like unchanging variables, but that just doesn't jive in my head, like, you know. So, you know, you can do something like this. Like that's sort of the first part of functional programming. Values cannot change. Once declared, something is sort of what it is, you know. The second thing that's important in functional programming is that all functions are pure. And what purity means is that what happens in your function stays in your function. Functions cannot mess with the outside world. So a lot of the stuff we're typically used to, like, oh, I'm going to start this function. Okay, let me fetch something from a database. Let me log this value. Let me do it. Like, you don't get to do that. Functions cannot touch the outside world. They can only take in values and return values. And that is actually really important because that lets us sort of like analyze this main function here. So main, this is how we do type declarations in Elm. It is actually my favorite thing about Elm and Haskell style languages. The type declaration is above the function declaration. So when I'm like scanning a doc, you just sort of like read the types. You don't have to like get into the weeds of parameters and stuff. So main returns an HTML and this sort of like object called a message, which is just like a placeholder for some other type. You know, so it could be like HTML int, HTML float. We haven't really told it what it is yet. And we have this string, which is hey, virtual coffee. And then we have this thing text here. So text is actually a function. And text has this type of type declaration. Text says, hey, if you give me a string, I will spit out an HTML message. So text is a string. We've given it a string. This makes an HTML message, spits it out. Note, the syntax is very, very light, sort of taking inspiration from, you know, basically the way you define math, like f of x equals yada, yada, yada. What else? Is there anything else that's sort of like interesting to note there? There's no difference between declaring a function and declaring a like regular object. They're lowercase. Types are uppercase, functions are lowercase, and you kind of go from there. So that's kind of cool. So what I wanted to show is like, what happens if we try and what happens if we try and pass in something that is not the type that it expects, this HTML message? And let's see what we can do there. So let's say if just main is 0. What does the compiler tell us? Hey, something's off, like the body is type number, but main says that it should be an HTML message, right? Which is sort of a typical thing of strongly typed languages. The compiler is able to sort of deduce what something's supposed to be versus what you tell it is. So, okay, how do we get this from a number to an HTML message? Well, there's a few convenient functions we can work with. So let's try the function from the string library called string.fromInt, which conveniently takes an integer and will return a string. So I'm going to take this and we're going to use something called a pipe, which basically just says pass the value on the left into whatever happening on the right. And we're going to hit compile again, and hopefully it yells at us again. Hey, yeah, something's off. Now we have this. It's like, hey, now you've got a string, but you still need an HTML message. So, okay, well, we already know the function that gets us from string to an HTML message. So we can just do this, and that should, there we go. Now, this is relatively straightforward, but this is sort of like the entirety of what functional programming really is, right? You have data and you're just passing it to functions, and those functions are transforming it into something else. So you're always just, everything's about transformations. And the definition of functional programming tends to be where object-oriented programming is about statements. I am object A, do this, do that, then do this. Functional programming is about expressions. You're not really saying what to do, you're saying sort of like what things are. And so your entire program body just becomes essentially like one large equation. And the compiler, because everything is pure and nothing can change, can like make sure that every single piece of it actually adds up. Like at the end of the day, like you have to account for everything. All the types have to match up. Everything's strongly typed. So I think one of the best things about Elm, and one of most people's most favorite thing about Elm, is that like the compiler will literally walk you through everything you need to do to get your program to match up. The big claim to fame you'll hear in the Elm community is that Elm has no runtime errors, which is a very bold statement and causes lots of programmers to roll their eyes. And the answer to that really is like, it is possible to get a runtime error in Elm, but like you actually have to try. Like the first time I saw someone do it, he was like, I tried for 3 days to get it and I finally figured it out. And I'm like, well, that's not, does that count? Elm won't really compile until like you've eliminated anything that probably could make a runtime error. Okay, so that's that. We are going to jump to this example. Ooh, we're getting a little fancier. Okay, so first things first, Elm is styling agnostic. You can style however you want. You can use CSS, you can use frameworks. There's Elm versions of Bootstrap, Bulma, everything under the sun. We have a slightly more complex version of what we had before here, right? So still outputting HTML, but now we see classic HTML elements, div, h1, text, etc., etc. And the main thing we want to like understand here is that these are still all functions. Remember, in Elm, your view is just a function. So div in this case, oh, gotta do that. Div is just this thing that says, hey, I take in first a list of attributes, then I take in a list of HTML, and then I spit out an HTML message, right? So this div, this first thing here, this is where we keep our attributes. There's our attributes. This list here is our other HTML element, and it's like a sort of like a perfect mirror of how you would normally structure a web app. I'm going to try importing something, and hopefully it does not break. So I'm going to go import HTML.attributes, and we're going to expose style. And let's see if we can add some sort of styling to this div. So we're going to go styling, we're going to do padding, and we're going to say, let's do like 5. And hope it doesn't yell at me. Oh, there we go. Cool. So
Quick question,
basically,
Kirk.
go for it.
Is the only way to develop Elm in the browser, or can you do it in an IDE or text editor?
Oh yeah, no. This is just for convenience sake. I decided instead of doing absolutely everything from scratch, I would just use some of these examples here. Yeah, no.
Okay, yeah,
You can do,
cool.
yeah, it's fine. You can do it wherever you want. That is a good question. I should have probably explained that from the start. That's on me. I'm terrible.
No, you're awesome.
We'll see. But yeah, so like again, it was just this idea. We're getting used to this idea of our views are just functions. We're just collecting functions, and functions are first-class objects, so you can just keep stacking them. I can break this up any way I want. It's fine. So like, let's say we wanted to isolate the header. Well, we could decide, okay, we're going to make some sort of header, and okay, header is. I'm just going to snatch this, paste it here, cool. And then instead of like having it all here, I can just refer to the header. I mean, I say that, let's like see if it actually compiles. Yeah, it did, and we're cool. If we wanted to add another element to our div, well, we would just add another element to our div, So let's add a h4 and this works. I'm going to compile. The compiler is going to yell at me. Boom. Hey, can't find h4 because we haven't actually exposed it from the HTML library. Thanks, compiler. I love you. Oh, and I forgot to actually convert my string to HTML. Boom. Okay, and we're back. And that's sort of like, this is like the most simplistic way to do the structure of your application in Elm. But like the idea that at the end of the day, it's just all functions. You're just passing in functions, and all this stuff is like stateless, right? So this will do the same thing every time, no matter what. It can't change unless you tell it to change. Like, it's just the way it is. But I think at this point, these are all still like relatively simple applications that we're not really doing anything important yet. We're not really getting any values from the user. So let's get some values from the user.
Kirk, can I ask a question?
Yep.
This is James. Is that empty bracket thing, is that an idiomatic pattern that you'll see everywhere, or is there some way to bypass that? If you never want to add attributes to your elements, can you just bypass that first empty list?
That's a good question.
Cluttered. You see what I'm saying? It's kind of cluttered, right? When you read it,
yes.
It's cluttered.
Well, yeah, okay. That's actually a good thing. I think, so normally when I am doing like the views, I would not use like the default stuff. So there's a couple other libraries that do like abstract a lot of this away. Or if you want, you can, let's see if I can do this on the fly. Let's make a function called stylus HTML. So we're going to make a function called stylus HTML, and let's have it take in, we're going to have it take in like some HTML object, and we're going to have it take in some list of sub-objects. And then I'm going to say, what I want you to do is return the HTML object, empty style list, and then like list of sub-objects.
So you're almost like currying the function.
Exactly. That's exactly what I'm going to try and do, and we're going to see if it works. Let's pick like a nice, simple one. So stylus HTML, and we're going to just do that.
Do you mind just, I know what currying is, but maybe just for everyone, I don't know if everybody's familiar with currying.
Yes. So the idea of currying, okay, so we're going to take a little jump back. So currying is the concept of, let's say you have some function, and that function takes in multiple parameters. Like it takes in an A, then it takes in a B, and then it returns a C. Traditionally, we would say like, okay, this is a function that takes 2 parameters and returns some value. But another way to think about this is that this is a function that takes 1 parameter and then returns itself a function that takes another parameter and then like returns a C. So what happens in functional programming, typically in like object-oriented programming, if you're calling a function and you forget a parameter, it'll tell you like, hey, I'm supposed to get 3, but you only give me 2. In functional programming, it won't give you an error. It will tell you, well, you've just made a new function that's going to take the final thing and then spit it out. A nice example is, let's do operators. So we know the typical operator, plus, you pass in 2 values to plus, it sums it, it gives you the answer. But we can make a function called add5. Add5 takes some value, and then it returns so we're using the plus operator, but we've only passed in a single thing. So what Elm is going to say is, okay, so you now have this thing here. If you pass this in an integer, it's going to add it to this. It's going to give you a value, and then that's sort of like the basics of curry. This idea that you can split functions up, or you can sort of like not finish the function and get sort of a new function in return, and it lets you do a lot of like parameterization and stuff. So what we're doing here with stylus HTML is we're saying, okay, give me just an HTML object, give me like one of these, give me this end part, and I will do the insertion in the middle and see if we can get that to work, except for through an error, which means I did something wrong, but I don't know what I did wrong, so let's see if we can find out. I probably just spelled something wrong. Okay, right, this is a capital, this says thing. Cool, and it still works. So this function sort of like bypasses the need to add those empty styles because it'll just do it for you. So that's kind of cool. Thanks for that, James. That part was probably.
I don't know if it's simpler. I mean, you're trading styleless HTML for 2 brackets, but it does look less symbol-y, I guess, right? It's more readable, I guess.
Yeah, that is true. And I mean, one of the things I think is key about Elm is that a lot of the traditional functional programming languages are very big on symbols. Like they're very symbolic, and they try and stay true to like the original sort of like mathematical notation. Elm, for the most part, has completely abandoned that paradigm. Elm always prefers words over symbols. So you will hear things like map and like and then and, you know, explicit calls to list and sums as opposed to just like abstract symbols, because that doesn't really help anyone. When Elm did that, the Haskell community that sort of came to web development through Elm were complaining. They're like, we need these symbols. And everyone was like, you really don't. And they just make it harder for other people to buy into this. And that's why we have to do this in the first place, you know? Elm is primarily designed for JavaScript developers looking to get into functional programming. Like the resources are made that way. The website, the documentation, it's basically geared towards, hey, you write JavaScript, try this out. So I would highly encourage the people here who do know JavaScript to try it out. Okay, I'm running out of time. Gotta jump forward. All right, so fancier. This is the buttons application. And now, big changes, folks. And we're starting to see that sort of Elm architecture that we talked about earlier. So still HTML, got some events, but now our main is no longer returning just HTML. It's returning this thing called a browser.sandbox, which is just a nice way of saying an isolated little program space. So you pass in the init function, you have an update function that it expects, and you have a view that it expects. So we're just gonna like walk through this script and sort of see what it wants. Step one, the model that we talked about, the state of our application. This, the simplest possible model, it's an int. There it is, there you go, so cute. You have to define an initialization for your model, something that the app knows what to do when it starts. You have to put an initial state for the model that is unavoidable. You can't escape it. And it has to be, of course, the same type as what you said, your model type is. Now we get to the message type. Messages are basically how you say, hey, I want some change to happen in this application. In this case, we've defined two messages, increment and decrement. Messages go into your update, and these two have to be in sync. So if you say, these are the ways my app can change, you have to handle those in the update and tell the app what to do. If you ever, whenever you change this, add to it, subtract, update will sort of like tell you, you need to fix me. And if you'll notice, the way we sort of look at the different things that it could be is with these case statements, otherwise known as switch statements. I know back in the day, they used to tell programmers, avoid switch statements at all costs. They're dangerous. They lead to messy code, yada, yada, yada. But that was more artifacts of the languages they were being used in. Functional programming tends to work with switch statements because we tend to deal a lot with these sort of like union types that are like, well, it can be this or it can be that. And it's sort of, perfectly fine. And then we have our view at the bottom. So now you notice we have a new sort of HTML element, the button. In its attributes, it actually has the on-click event, and we're passing it in when you on-click, pass the message and the text. And we can see here, this happens and this happens. And I think sort of the best way to kind of illustrate what's actually going on here is let's try and add another button that says doubles the number that's in the model. So first thing I would probably do is I would go to the view and I would say, okay, let's do a new button. I can't type, there we go. I'm gonna call this button double. And we're gonna skip the message for a while. So let's just say it's like that. Let's compile, let's see if that works. And if it adds it, it does, it's called double. Doesn't do anything right now because we haven't added an associated message. So the app won't change anything. We're gonna use an on-click again. So there's on-click, there's all the typical stuff. Press down, right-click, etc. But what message are we gonna use? Well, we need to make a new one. So we're gonna go here. Let's call it double. I'm gonna hit compile and it's gonna yell at me. Hey, your case statement in your update does not have branches for all the possible messages that your application has. And the missing possibility is in fact double. The first time I encountered Elm's error messages, I was kind of taken aback after I'd spent so much time in like Python and C# world where you just get like an ugly stack trace. Or my favorite one, the instance of an object is not like, what does that even mean, This is something that I can actually follow, and it actually, like helps you try and figure out like what the problem is. So what it's saying is we actually have to deal with double. So when it's double, well, I want to take the model and I want to multiply it by 2. So no, this is the only place you can change your model. Nowhere else lets you do that, right? Views can't change anything. They just take the model and they do something with it. Messages are static, like everything else is completely static. This is the only place. So let's see if it is happy now. It is happy now. And hey, we can do the thing. Cool, cool, cool.
Quick question, Kirk. Is the normal convention for Elm to write the view and the model all in the same file, or is this for demo purposes you're just keeping it together, or?
It's completely up to you. Because this app is relatively small, we're keeping them all in the same place. People have different organizational styles. Some people keep all their views in one spot, all their updates in one spot, the models in separate. Some people componentize it. So all associated model updates and views, they'll keep in one module. And then you will just sort of like your sort of like master or control module or model will just like aggregate those. I have an example here of like a large Elm app that I want to show you guys after. I just didn't want to jump into it, but we'll see sort of like what does a real app look like with Elm. But yeah, that's a good question. So I mean, it's completely up to you, you know.
Yeah,
I've
cool,
written
thanks.
something I think that's big in functional programming languages is that you really sort of don't break things out into modules until you see a need for it. Something that's always sort of bothered me in other languages is like I'll be going through a code base and you'll click a file and it'll have like a single line, or like a single function, and you're just like, why is this isolated? Like, why do we have all these different folders? I've written 1,000, 2,000 lines of Elm and like not felt the need to split it out into a different module. But it goes by you. You know, if it's coherent and everything makes sense, then you can do that. What people do tend to do though, when they have it all in the same place, they do use like just little comments to isolate out the model, the updates, the views, and keep that separation. Okay, so I had one more sort of little demo I wanted to show you and work through. This one's sort of the most complex we're going to get today. The cards one. And this has to do with a random generator. So I guess sort of question for the audience. When you think of a generator, can we call a generator a pure function or not?
You're talking about something that yields?
Yeah, so the idea
Okay.
is, yeah, would you consider a generator to be a pure function?
I don't think, well, depends on how you implement it, I think. Because
Right.
like you go to next steps and stuff, but there's nothing stopping you from saying, hey, I'm totally going to overwrite something, you know?
Yeah, and I guess the way we sort of look at it is a pure function is something that when you put a value in, you get the same value back out, right? It's like when you did math class in school, f of x is x plus 2. If you put in 2, 4 comes out. You can do it a million times, 4 comes out. Like if 7 comes out, the universe is broken. And that's how our pure functions in Elm work. Like that's the way your views work. Like this view will always be this view unless the model changes and tells it to do something else. But if you think of a random function, the definition of a random function is that you put in the same input every time and it gives you a different value. So random functions are not pure functions. They're sort of like the most impure functions. So how does Elm handle that in a place where we say like nothing can change? So for that, we have to slightly make our system a little more complex. So no more are we in the stage of the browser.sandbox. Now we're in browser.element. And that basically just says you're now dealing with an Elm app that can take feedback from the outside world. And now we have this extra field called subscriptions, which is basically how Elm listens in to other things it might be trying to communicate with your app. So we have this draw app here. We hit draw, it does a thing. It's very cool. I just found out that Unicode has these, and now I want to make like a whole like blackjack thing from it. That's actually, I'm so excited. Okay, so let's take a look at the app. So first we look at the model. Functional programming, I wish it was called like typical programming, because it's really about your types. Like it's really about your domain. If you nail down your domain, the functions are just glue between like your stuff. So we have these cards, our model is a card, and we have this init. And note our init is slightly different now. So before we were just getting a model, passing back a model, nothing else. Now we have these concepts of commands. And commands are basically a way for your Elm app to send a message out and receive messages back from the server, HTTP requests, file IO, anything outside the application, you can use a command to get them out. So our initial state says we're going to start with a 3, but no commands as of yet. When we get down to our view, I want to jump to the view before the update for a little bit. So view says we're just trying to show the card, but we have this card type. There's really no native way to represent a card on the screen. So we have this little function that takes a card, returns a string, and the rest is pretty much what we've seen so far. Okay, let's get to the fancy part. Our message, we have 2 messages. The first message is the draw message. The second message says new card, and it has an associated data type, which is a card. So what's basically happening here is you click draw, goes to the update, hey, the draw message was called. I don't want to change the model yet. What I want to do is call this generator command. Go out, generate a new card, pass that back to another message that says, hey, we just got a new card. And that is the one that actually updates the model. So you have to send two commands, basically. One saying, hey, I want you to send something out. And then, hey, I want you to bring something back in. So in this way, you have this way of actually talking to the outside world, but you still get to keep everything else in your app completely pure. You still get to maintain all your basic functions. Nothing has to change. You're not introducing any state. And it's a very, very safe method of actually talking to the outside world. So I think when we talk about Elm, one of the main things I'll say, like one of the things most notable about Elm compared to the pure scripts, the type scripts, all these other things, all the other things have to be backwards compatible, right? They have to allow JavaScript. Elm absolutely does not allow JavaScript to like make it into Elm. It communicates through JSON, but like you have to, it's like if you say like, okay, I'm expecting a JSON file, you have to tell Elm exactly what the shape is of the JSON that you're getting back. And if the JSON that's sent back is wrong, Elm will reject it. But you also have to tell it what to do if it gets back JSON that it can't accept. So you're never in a state where like you A, accepted JSON or accepted data that you can't process, or B, you can't process the data and you get an error because of it. Like it just won't compile. You have to deal with like both of those expectations. And that just, I think the big thing about this sort of like framework and this kind of methodology is that it's not just that you get less errors, but it's that there are classes of errors that just cannot be made, right? Like things like overwriting a variable is just an error that like cannot be made during this. Not handling exceptions or things that just cannot happen. The app will not compile if you don't handle them, because ultimately everything has to return a type. We're typically used to error handling by like, okay, it throws an error and we do a cache accept and we work through there. But in Elm, errors are not separate from application flow. Like they're expected and you have to sort of deal with them as part of the normal application. So all that to say, you know, I can hit draw and I can make a fancy card thing. And see, what I wanted to do originally was we were gonna like work through actually turning this into a full blackjack application, add more cards, see how the types change. It's like a really fun process, but I've rambled so much and we're getting close on time. So I will sort of like pause here for questions, comments. If you guys want, we can sort of take a look at a real Elm application and see like what a bigger structure would look like, but you know, up to you. All right.
I know one thing I've run into, not in Elm because I've never used it, but I've done a lot of TypeScript. So it's the same idea. You know, it's a strongly typed language. So so like your example of the matching the JSON so that you don't get errors, you can get your application to pass, but there's nothing. It depends how you create the types for the JSON that you expect. Like if you don't use a code gen tool to do it, what can happen is you can get a disconnect between the actual API calls and the type that you're expecting. So even though it says like the payload should return a message and a status, if somebody doesn't keep that in sync with like the real API, then even though the program is correct, what's coming, like the external stuff, like from the network, it can break it. But that's just kind of more a thing for developers to be on top of to make sure that stays consistent. But
oh yeah, 100%. And I think that's the thing, because Elm is so strict, a lot of people have discovered like, oh, what they thought they were sending was what they weren't sending. I remember, I think early on, there was a problem with one of the like one of the like the React Redux applications. And then they found out like, oh, this just happens to be sending like weirdly bad JSON, and we didn't even know. So people have like discovered flaws in their API simply because they tried using Elm, and Elm was like, that thing that you think that you're sending is not what you're actually sending. And I mean, Elm is probably the strictest environment I've seen for this type of thing. And there are times where people do get frustrated because they're like, I just want to do a thing, and you're forcing me to think in advance, and you're forcing me to decide what I want before I actually implement it. And sometimes you just want to like go. But I think the argument there is like, in the long run, you just feel so much better knowing that like you did the thing up front. And because of Elm's like safety, and because you're in this space where you know, okay, I cannot break this application, it makes it really fun to refactor in Elm, because usually like when I want to refactor something, I will just dive in, just change the model to what I think it should be now. And then I just hit compile, and then the compiler will go through the entire application and be like, okay, here's every single place you need to hit to make this all be back on track. And that type of security, you know, I talked earlier about like empowering you when you're just learning to program and you're just trying to get into web development. That's really nice, knowing that like, okay, no matter what, like I can make this thing work, and whatever I put out, you know, it will work. Like for my Elm app to break, like everything has to break, you know? And I don't know, that's just, I've really enjoyed it. I've really enjoyed working with it. I've made some really cool things. I think everyone should try functional programming, because one of the main things it does is you get really good at this type of like this sort of domain design. Like, what is the actual state of my application? And you're not forced to use primitives, right? So like, we didn't have to say, well, card is an object that takes a string that kind of knows what it is, and you're like, no, like it's a card. Like, what is a card? Like, it's just a two. It's just the concept of a two, you know? And you're never forced to live in that space of dealing with primitives and changing stuff around. I remember, so when I was going to upgrade this, I realized that I needed to make a deck, and then I needed it to pull from a quote unquote deck of cards. I'm like, oh, but I have to deal with the fact that sometimes the list will be empty. And then that made like the API a little more complex, because I'm like, oh, I have to do all this extra stuff from an empty list. But like, I do have to do all that extra stuff from an empty list, because decks can be empty. So like, I can't just like ignore that logic. And I was like, no, like you said, it's a list. So my options were, well, I could make it, I was sort of telling my partner about it. She's like, what if you just made it like loop? What if you just made a list infinite? And I was like, hey, yeah, I can do that, right? It's like, we know a normal list, you can have, you know, just like an empty thing, but like you can make this thing, and I frequently make this thing in my code called a non-empty list, right? Which type non-empty list equals a so the type signature of this, like, so this says like it has to make this, to construct this, you have to give it some value and then a list of that value, right? But that means that no matter what, when you try and make this, you have to have at least something here. There has to be at least this. So you could have, making all the funny noises today. You know, I could say something like this, right? 4, and then this is a list of integers, but it's empty, but like you have to pass in something. So in Python, when I try and do stuff like this, like I have to make a full class. I have to do like methods and attributes and qualifiers and all this stuff. In functional programming, like it's just, I don't know, it's so quick to take the domain in your head and just like put it into the code, and it understands like, okay, I know exactly what this is and we can work from here. And that's just like a super, super valuable thing. But I know, okay, we're very, very low on time. So just gonna quickly show you like a real Elm app. You guys have probably seen this before. It's like the example real world app that Conduit has, and people usually test like frameworks and APIs against this. So there's like a React version of this. There's Angular, all the major frameworks. And it's kind of got everything that a real app sort of basically has. A homepage, sign in, sign up, these all have to work. You've got a feed. It's the internet, so of course the tags that people put in are humanity, Hitler, dragons. You know how that works.
What?
You know what the internet's like, Chad. So we're gonna jump into the actual code base.
Hey, Chad, do you mind muting? Because there's like a lot of air noise. Thanks.
So the code base, relatively simple. Again, we have our standard sort of index.html file, all the stuff you'd expect to see. There's our little Elm app embedded in it, with some extra stuff for event listeners, for local storage and stuff like that. We have tests. Elm has sort of really cool testing suites. We're not going to get into that. Kirk, stay away. And then here's the source. So going back to what I think, Nick, you were asking about earlier, you have the option to kind of break it up however you want. This author decided to make each page be its own separate module. So in each page, he's like, okay, well, this is the view for this page. Like, this is everything I need for this page. This is the model for pages that require like stuff that changes. This is status, loading slowly, feed tabs. Like, so he just modularized the entire application. These are the messages specific to this page. So you can always like break it up that way if you want. And then in your main, you just sort of like pull it all together, right? So you just import everything else, and our model, redirect, home, settings, and the model is just composed of the individual sort of data types from all the other parts. The view just passes like the view functions from the module. So it just takes it and just throws it to them, and then they know what to do. The message, again, just amalgamates. So the nice part is like, it's just all functions and data. So you can split it up and break it off like any way you want that you think makes sense for you. And yeah, so this is more like what a real sort of full app would look like. And note that this is a little more complex. We have our init, but we also have some stuff here to handle routing. But a small Elm app and a large Elm app look pretty much the same. At the end of the day, your model that doesn't change, your view functions that turn that into HTML, your update that handles the messages, and commands if you need to talk to the outside world. And that's pretty much it. And I'm really into this.
Do you find it difficult when going into editing an application to figure out where the hell things are coming from? Like with this structure, it might be difficult to know. You probably have to follow the breadcrumbs. But is there any way to like put like a debug mode where it'll put comments in there to say this came from this file or anything like that?
Oh yeah. There's totally a debug mode. I think I can show you that in the Ellie app. Oh, okay. So that's another thing we should talk about actually while we're here. So Elm's package manager forces semantic versioning. I forgot to mention that. That's also like very neat. If someone has a library and they make a breaking change, Elm will force them to upgrade the version number accordingly. It won't accept it if they don't. Also, when Elm does a major version upgrade, the packages will stop working because they're not valued for that. And people have to actually update their packages. So you never have to worry about like a package being incompatible. It just won't let you do that, which is kind of fun. But going to what you asked, yeah. So you can do debugging. Let's see if I can remember how to do that. Import debug exposing log. But debugging is like very interesting in Elm. Everything's a function, right? So the log function says, hey, give me a string as a sort of like a header for what you want to log, pass in the thing that you want to log, and then I will return it right back. So the program doesn't know, what's happening. So here we're going to say, okay, let's log this number. Let's do something a little clever. Initial number and then 0. And if I did that right, that should compile. No, it did not. I did something wrong. What did I do wrong?
Terminate your string.
Are you missing a
Ooh.
quote in your string?
Yes, I am. You guys are just as cool as the compiler. Hey, so it still works. And if we go to logs, you can see, hey, initial number 0. So you can do that. Worth noting, this only works while you are like writing your application normally. When you hit build, it will force you to remove these like debug logs and debug to-dos, because these are they're not like pure, it's not a pure function anymore. Like it's a side effect, and Elm can't control like what these things do on the side. So you can't leave these in your build application. Perfectly fine while you're writing it and testing it, but it will make you take them out, which is, again, something that people are like, that feels like a lot, but how many times have you accidentally like left stuff that you were using to debug in your actual application, you know? So it just sort of forces you to deal with those things up front.
That brings up a, sorry, go ahead, Chad.
Oh, no, go ahead, go ahead.
I was gonna say, well, just to your point there, Kirk, I was wondering, because obviously the Elm project isn't as popular as like React or Angular or anything like that. So
yeah.
Can you integrate like linting tools to it? And is there like, one of the things for debugging is, because like even when you use Babel, which converts your code to be able to run in whichever browsers you support, you get this source map generated. So you could, is there any way to connect the actual Elm code when you debug with the actual code running?
Yes, that is not something I've explored too much, but I know there is a testing framework that lets you like work at the, I don't know if you want to call it the output level or the actual HTML level, and you can sort of like write tests based on, well, I expect to see this div or like this particular class. You can do that. Also, what I wanted to say, so Elm actually, the Elm community is a big proponent of this thing called Elm Format, which is, you know, like one of those linters like Flake 8 or I think Python Black, or Brian knows more about this. But so like everybody pretty much formats their Elm code the same way. Nobody talked about it, but like this, where do we go? This is really weird. This style is really weird, but I've been doing it for a while now, and I'm super into it, of putting like the commas beforehand and everything. But like nobody, like it'll style it for you, and everyone's pretty consistent on that. Elm is less popular than, you know, the other frameworks, but it's got quite a bit of tooling around it. So like all the major styling libraries are there. It's got like full test support, full linting support. And I mean, Elm officially is on version 0.19, but I don't know, that number doesn't really mean anything. There's a few hundred companies right now using like Elm in full production. Like 90% of their Elm code is, 90% of their UI code is Elm. All the major, I guess, software houses have at least some part of their stack that's in Elm now. Like, so, you know, it's around. Because again, the main thing is like, you don't have to do your entire app in Elm. You can just do a piece in Elm. One of the nice things about Elm is that the JavaScript that it compiles to is kind of like, it's like very hyper efficient JavaScript. So after you do the normal stuff with like Uglify.js and certain, it's smaller. The asset sizes tend to be smaller than things like React and Angular. And it also tends to be like slightly more performant. So you're not taking a performance hit for switching to Elm. Like it's just, you know, the overhead of having to learn a new thing, but people tend to really like it. Honestly, I think the big thing about Elm is like, it's not even the functional part. It's the fact that like they spent so much time making it easy for people to get into. Evan took a lot of inspiration from like the Python community, right? Like it's not like Python is like that much better than Ruby. It's just that like Python like put itself in positions where people who were new to code were like, hey, I can get into this, right? Like scientists found Python, and Python is like, yeah, sure, like this is very easy to get into. But Python has like a very much like, this is how to do things. And for new developer, like for new people, I don't want to have to like make decisions, right? Tell me what's the best thing to do and I'll do it. Elm is very much like, we think this is the best thing to do, so you should do that. In fact, in the latest version, Elm removed some features. It made a lot of people upset, but Elm was like, these things are sort of like confusing. Like if you're into functional code, you know what this is, but if you're not, so like why even keep it here? And everyone's like, oh, it's elegant. It's like, elegant is not a real word. Like elegant code is code that people can read and write and understand and share, you know? So that's why I would say, like, if you want to get into functional stuff, like let's say you don't even care about like actually, if you just want to like learn functional code, I would 100% start here. I had like a weird moment when I was getting into this. I was writing Elm for a few months and I had like this big like galaxy brain idea, and I went on the Slack. The Slack's really cool. They're very friendly and super helpful. I'm like, hey guys, I discovered this thing. If you write like modules like this, you can be like, oh yeah, that's a functor. I'm like, what? Yeah, that's a functor. Like that's been a thing for like 75 years, but like I got to discover that on my own by just writing the code. Somebody didn't tell me, hey, read this book on maths and then come back. So like I started making intuitions about like what good code is. And it turns out like that actually does match up with the theory, because that's like how people are encouraged to write the code. Like we went through this entire talk. I didn't have to tell you about abstract data types or monads or whatever nonsense people tell you is like important. We just wrote some code, some good code, that's fine. Sorry, man, I am talking a lot.
In your experience with Elm community, so this is the front end code. What is typically the back end code stack that a lot of the folks are using? Usually things kind of go like peas in a pod. What are they doing?
It's pretty diverse actually, because I mean, a lot of people, it depends on like what you have control over, right? Especially if you're using Elm at work, you probably already have an established stack. People who get to do the whole thing ground up, people usually like going functional all the way. So like Elixir and Elm is like a really popular combo. F#, F# liked Elm so much, they have a library called Elmish that just like does the same thing. So it's just like F# all the way. So that's really cool. But I've seen people use just about everything, but okay, I need to stop actually, let's take a step back, because I realize I've been like very positive about this, but I do want to tell you like a full scope. So like, what is not good about Elm? One, Elm is that whole like restriction of what can go in. Like Elm does force you to do a lot of sometimes like not hard, but like tedious things up front. And some people do not like that. Two, Elm is not a democracy. I know in the JavaScript ecosystem, it sometimes feels like JavaScript libraries like have shareholders, like the community's like, oh, we want this or we want that. And people release stuff saying like, this is what we're gonna give our users. Evan is the sole maintainer of this code. He's the one who writes it. He's notorious for spending a long time between releases, because people say like, hey, just do this fix, just do that. But he might be working on something that like make a whole bunch of things obsolete at the same time. Elm, while absolutely in production, Elm is still growing, and there will still be like major changes to the API in the future. Like right now it compiles to JavaScript. One of the things they've been thinking about is having it compile to, what's that other one? The web thingy. I'm blanking.
Web components.
Yes. So like that's still a thing. So like if you're looking for something that's just like established and will never change, maybe not. Also, there's the issue of just like it's still new and there's not that many Elm developers yet. All the people who do write Elm would love to write Elm at work. I would love to write Elm at work, but it's just like who's offering that. I just wanted to like plug that in there instead of being like, oh, this is amazing, use it for everything. Like absolutely not, And there are some times where there might be some functionality that is handled perfectly well by an existing JavaScript library, and the interface with Elm might be tricky, and you might just want to just keep it in the JavaScript library. But I've yet to encounter a situation where I needed to reach into JS to kind of get something out, and there's more libraries coming each and every day. But how did we get here? So yeah, you can, your server can be whatever you want. There's an alpha project by a couple of folks who are making Elm on the back end. I'm really excited about that because it sort of is not using the traditional like data table structure for storing data. Like it's sort of keeping it sort of like these types I've defined in the model. So you just say the shape of your data and it says, okay, we can work with that. And you just have one type system throughout the application. That's very much in the alpha stages. I'm subscribed to their newsletter. So, you know, if that becomes like a thing, I will absolutely tell you about it. But for now, use what you like, I think.
So I have a few questions that I wanted to ask. Like when using Redux, I believe one of the things about Redux is because you generally avoid mutating the state when you're debugging the application, you can actually replay the application backwards.
Yes.
Can you? So I was asking if Elm can do that.
I got so excited about it. Yeah, so we didn't show it in this one, but Elm does have, they call it a time traveling debugger. Since the model is just like a series of like snap states and you know exactly what caused the state, you can go back and forth in the application. Yeah, so that is a nice thing for testing. You can go through the entire thing and then like go back and forth, and that's really fun because that is the only state that the app has. Everything else is static, so that's pretty cool.
Right. I guess the second question, you might have answered it already, but I guess about building like, or about, I guess, the application build. Like, I don't know necessarily how to describe it, but like when you want to deploy an Elm application, what does that look like, if that's even?
No, that's a relevant question. And I think that the answer is it looks just like deploying a regular JavaScript app, right? Because like when you hit build, there is no more Elm. It just becomes like an Elm. Okay, we can jump back to this and see. So, whoop. Why do I make all those noises, guys? We got to talk about this. So a couple of things I didn't show. So like the elm.json, which is just storing all the packages and dependencies you're using.
Right.
And then source, where is it? You might have not included it in the build output. But typically, at the end of it, Elm will just spit out a file called elm.js, right? And that's all you see. And the rest of it, everything else is the same. You know, you've got your same manifest files. It's all the same as like regular web deployment. There's nothing particularly fancy there. Like, it's Elm up until you hit build, and then after that, you know, you're basically just handling like any other JavaScript app. Yeah.
So you handle, so what I'm thinking is you write Elm.
Yes.
And then you hit build, and it spits out I guess compiled JavaScript.
Yes.
A JavaScript file, and then you take that JavaScript file and you host it wherever.
Right. And I mean, you have the option of that can be your sole. So here you see source. There we go. Source elm.js. So like that can be your sole JavaScript in your application, or you can have other stuff, and Elm is just like a node that it can reference, you know? So you can embed a tiny Elm app in a surrounding JavaScript application like anything else, you know? So it really doesn't like force you to be all in. You can definitely just tailor it to whatever you need.
Okay.
So does Elm? Oh, sorry, Chad. I was just gonna. Does Elm have like all the CSS, you know, like processing for anything else like that, or do you need to go also get Webpack rolling or you know whatever to?
No. No need for Webpack. So like, I mean, when I tend to develop in it, there's a couple. There's like Elm Live, which is like the whole like Webpack Babel stack thing if you want, but none of that's necessary. I mean, because I don't like writing my own CSS. I'm very bad at it. I'm not good at CSS and styling in general. If I had time, I would have showed you guys something called Elm Ui. It used to be another name, they called Elm Ui. It's this guy who sort of said like, okay, if we had to do styling from scratch, forget CSS, so we just had to do it from scratch, what would it look like? And right now it's like my favorite way to do it, but it has some very, very big changes from like the regular CSS stuff that I think is really cool. But you're very much pick your own poison with how you want to handle that. Elm, as long as you're satisfying its requirements about the model and the updates, you know, and like your HTML for your views, the rest of it is up to you.
So I guess one more question, kind of back to the build idea. So when you're testing in Elm, you're trying to get the code into the browser. How does that work? Is it the same hit build, get a JS, and you just...
Yeah.
Oh.
So I mean, if you're unit testing in Elm and you're just operating in Elm, right, and you're just, you know, testing the logic of your application like normal, there is another test package called like Elm Explorations, and that's what I was talking about earlier, that lets you sort of describe the HTML that you want to see on the page, and it will check the output of Elm versus what you expect, and you can get granular like that. I have never particularly used that because I don't know, I just haven't hit a use case where I've really needed to get into the weeds of that kind of debugging, but it's absolutely there. The guy who actually works on a library streams like pretty often. He has pretty good streams on, like, if you want to just like see somebody like work in Elm a lot.
Is that Richard Feldman?
No, okay, Richard. Okay, so like Richard Feldman's in charge of No Red Ink, right? And they're a ed tech company, and they started using Elm, and then they liked it so much, they just hired Evan, like the language creator, and his job there is to just keep working on Elm because that's like their entire stack. So he's done a lot of evangelism for Elm. And I think like Elm has like a small group of like trusted, valued people. Like he's one of those people, you know, the secret council. You know, he's one of those guys. He's pretty cool. He also plays a lot of Magic the Gathering, so can't be that bad. But this guy's Aaron Vornerhaar. He used to work for No Red Ink. He doesn't work there anymore, but he made that Elm test package, and he also made Elm Format, which is the linter I talked about before that just makes everybody's Elm code look exactly the same, because I do not have time to die on like styling hills. So it just, everybody agrees that they would never pick Elm Format like its decisions for how they would have wanted to style something. So everyone's just kind of like equally, okay, I guess this is fine. But that solves a lot of problems. Yeah. You know, it's just, guys, I can like write web apps now. I still don't know. I'm still so bad at JavaScript. But like, okay, like gun to my head, like I could write a JavaScript function, or like, I don't want to. This is cool.
The pipe operators coming to JavaScript.
Yeah, I mean, that's the interesting thing, right? Like it used to be, you could say like Java is purely OOP, or like C# is purely OOP, C++ purely OOP, but like they've just been slowly sneaking in more and more functional stuff. Like Java's got like stateless functions. I'm like, what is going on? I mean, I love the pipe, but the pipe makes you do like stupid things. What were we looking at like the first time? Like, remember this one? So the pipe makes you want to pipe everything. So like you'll see people write code like it'll take the 0. Okay, I'm gonna pipe that into like log initial number. And then I'm gonna pipe that into, you know, and then I'll pipe, and then like you see people like do this, like they'll just pipe everything. And it's like, you don't have to pipe all of it. You can just, it's okay. Fun fact, there's also a right pipe, but we don't talk about it because everybody hates it. It doesn't look nice. Like this looks nice, the right pipe doesn't look. Also, like this is sort of like how you would think about an application, right? Like this is what I start with. I have a 0. Okay, I have an integer. I need to log it. This is my log. Okay, I need to turn it to a string. Okay, I need to turn it to HTML. So this flow tends to be the way most people operate. Okay, what's my input? And you just transform until you get to your output. The right pipe is like you start with your output and you go backwards. Who does that? Robots. Yeah.
And they can't even detect street signs in a picture. Come on.
I mean, Listen, every time the street sign has like the sliver of the sign in that one square, and I have to spend like 10 minutes like, oh, if I guess this wrong, I become a robot.
You get into like philosophical discussions like,
Yeah.
is the corner of a street sign, is that actually a street sign? Like,
what is the street light?
what about a post?
I gotta go. I got a meeting, but thanks a lot, TK.
No problem. I know some of you guys have to head out. I mean, so at this point, I would say like, thank you all for coming. This is officially it. If anyone wants to hang around, I'm gonna stay here and actually turn this into a blackjack app, and you can kind of like watch that. I mean, I'll talk through it, but it's gonna be a lot more like quick paced if you think that's cool.
This has been awesome.
Yeah,
cool.
Agreed. Thank you, Kirk.
Okay.
This is really cool.
I'm
Yeah.
glad.
That was dope.
I had so many more slides, and I was like, oh, but this slide, I just want to.
I think you made the right choice, man. I always get way more into talks when the speaker just starts, talking.
I'm
Enjoying it.
From their
Yeah.
like head,
James talked, like he had a bunch of like actual snippets, which I really like. Like, this is the actual thing, and he's like, this is what comes out. This is the thing. This is what comes out. So I like that. Okay, who has got 10 more minutes?
I can do it. I
Good?
can hang.
All right.
I can
Cool.
do 10 more minutes.
10 more minutes.
Are you gonna record?
I could do 10 more minutes, but I'll be right back.
Yeah.
Are you gonna record the blackjack?
Well, I mean, I guess until we stop, it's still recording. So.
Yeah.
Oh.
Yep.
Yeah. Kirk is the host. So as long as Kirk is here, it'll be recording.
Okay.
Bonus content. Okay.
Yeah. You can
So.
watch it later.
Well,
It'd be great.
I'm gonna head out, so I'll see you guys.
All right, man. Thank you for coming.
All right.
Really appreciate it.
Thank you for the talk.
Okay. All right, guys. So we're just going to do a quick thing. So like right now it's showing one card. Let's do 2 cards. Ooh, 2 cards. I'm going to get rid of this because we don't need this anymore. So our model, so this is a record. So that's why it says alias and not just type, because it already is a type. We're just saying like, we're going to give it a real name. So let's actually call you first card, and then let's make second card. Bold move, Kirk. That's also going to be a card. I'm going to hit compile, and it's going to complain everywhere, which we love. Boom. Step 1, something's off with the second branch, and you're in it. Model new card. So because we said it now takes 2 things, it actually now thinks that this is a function where you pass in another card, and then it gives you back a model, which is the currying we talked about earlier, right? It doesn't tell you you're missing an attribute. It tells you, hey, you've got a function when you really want a value. So let's do 3, 5. Did I mess that up? Actually, let's just do like a proper record. Let's be cool about it. So we're gonna say first card equals 3. And we're gonna say second card equals 5. I definitely didn't spell that the way I did at the top. Now it's gonna go all wrong. Cool. Are we still wrong? No, I don't know. What else do we need to do? The model does not have a first card field. Okay, so it's complaining in the view. So instead of doing that, I zoomed this to 125% because I realized the original size was like not ideal, but now I'm regretting that. So basically, I mean, and this is sort of like Elm development in the wild. You change your model and then you kind of get a feel for all the places that you're gonna need to mess with. But basically, like now that I've said the model is these different things, I have to make sure that everywhere else that is actually addressed, right? So the view no longer has the concept of like just the card. The view has a first card and a second card. So I need to do that. This stays the same, so that should be cool. We still don't have subscriptions, that should be cool.
I think your update doesn't handle the new fields right.
Exactly. So this is going to be the fun part. So here, update says, well, I do the generator thing and I get back a card, but now we need to get back 2 cards. So I'm going to tell it, instead of bringing back a card, let's bring back a pair of them. But then it's going to get mad because it's going to say like, hey, like here you have this new card thing. So let's deconstruct that. So let's call that card 1. Let's call that card 2. So now, okay, we're telling it we're definitely going to get back 2 things. And then it's going to complain here because like, hey, your model only takes 1 thing. You've got to change. It's like you're constantly going through this thing of like, I got to, everywhere's got to change until, you know, basically the math checks out. First card equals card 1. I'm obviously saving the generator part for last because the generator part is the weirdest part. But that's okay. We don't have to freak out about that. Where are we getting? There we go. The second argument to generate is not what I expected. So right now, generate, we have this card generator. Brian probably knows about this. It's a uniform function. You give it a list. It just takes 1. Luckily, we can be saved because there is something called random.pair, which takes 2 generators. I can just type it out. Am I even, guys? I love strongly typed things. So random.pair says, hey, if you give me a generator of A and then you give me a generator of B, I will give you a generator of A and B. Cool, cool, cool. So we're gonna make double generator, boom, boom, boom. And that is just going to be random.pair, and we're just gonna pass in our card generator twice. Actually, I don't actually need to use the braces for this. Not a big fan of parentheses in functional programming. So here, I should be able to replace our old card generator with our new double generator with double generating action. And let's see if that works. Hey, pew, 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 pew. So in that sort of crazy scatterbrained helter-skelter way, that's generally how things go, right? Like, okay, I need to do a refactor. How does my model change? You change your model, you hit compile. The compiler is like, okay, well, you're gonna have to change the update. This is what it is. This is what you need. You're gonna have to change your views. This is what it is. This is what you need. You're gonna have to change your message, like, and you work your way. Do you guys hear that? Okay. My laptop's in Portuguese and it's telling me my battery's dying. It's fine. We got a little bit of time. But that is how that process works. And that will work for like 100 lines of Elm, 1,000 lines of Elm, 10,000 lines of Elm, because like at the end of the day, the whole thing is still essentially just like one large expression, just like one large equation. So if anything is off, it will traverse and tell you, hey, here, 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 here. And once you're done fixing it, your expression is sort of like complete, and you can't break it because like there's no state that can be changed to put it in an invalid state. So a typical example is like when you initialize an application, sometimes you'll have certain components and you're like, oh, this is enabled, this is disabled, this is whatever, and you have them in that state. But like, why are you even having to initialize things if they don't need to exist yet? We're just gonna quickly look at, I was gonna click the cat gifs one, but you guys, you don't need that. This is a typical, what I wanted to show you is this. This is a typical sort of style of writing things in Elm. What happens when we try and do our HTTP GET? Like either we're loading the HTTP, we failed, or we got it and we got something back. But note, like loading and failure don't have an associated data type, because like if it's loading, there shouldn't be a string. And if it failed, there shouldn't be a string. So it's not like I have to have an empty string until I fetch something. Like there's no, the concept doesn't need to exist, because it's, I only want it on a valid case. You know, so that's the thing you sort of do a lot when you initialize applications. Like when you're loading, nothing's there. You don't need like the user ID field until you've actually connected the user. So you never have to deal with issues like, oh, something persisted or some state stayed that like I forgot to clear out or is like clogging up, you know, you can, there's a really good talk by Richard Feldman called Making Impossible States Impossible. I will drop it in the Slack, and it deals with exactly this, like using functional programming to make your types so that like bad things can't happen. You know, if you're doing ages for your clients, right, you don't say like client age is an int. You'd say client int is like a person age, and you can design a domain that says like, okay, if it's less than 0, that's like, you spend a lot of time doing that sort of type-driven development and domain-driven development, and that's like my favorite thing in the world. Like really nailing down the business logic and like the business domain, and then you will eliminate, you know, like half of your errors later on. Because like we all know, if your domain is bad, you get like hell later when it comes to actual implementation. And Elm's cool for practicing that too. Okay, that's it. Thank you.
Have you seen state machines? Do you know, like, have you looked in those at all?
Yes.
Reminds me of this a lot.
Yeah, and yeah, I guess, I mean, it really does operate like a state machine, right? Like you're always transitioning to a valid state. Yeah, that's a really good way to think about it. You're always, it's impossible to not enter, it's impossible to go to an invalid state because you've defined the mapping.
Exactly, yeah.
That
Basically turning your view into an event stream, right? That's how I think about it. That's why you can go back in time so easily, because really it's just a series of events that happen. If you need to know what happened here, you can just replay from the beginning because the events are immutable, and you know your starting state, right?
Yep.
It's like a fold right starting with the initial model.
Yes, that is also, this is so cool. I'm so glad I have people to talk about this with. But yeah, I mean,
nerdy to me.
Exactly. If I had more time, like for the people who aren't used to functional programming, I like showing them how to like define like the length function, the string.length function. Because like length is just this thing that takes some list of A and like it returns like an int, right? But it's like, and how would you just define that? This is like one of the first things I did in functional programming. Like, okay, well, I'm going to take some list X. No, let's not use X. Let's use like list one or something. And it's like, well, what is that? And it's like, well, case list one of, well, either it's an empty list and then I want to give you back 0, or it's a list of like a single value in it and then I want to give you back 1, or it's a list of like a value and then some like rest, in which case I want to give you 1 plus like length of the rest, right? Because there's no conventional loops in functional programming because you can't have an iterator. So like all loops are recursion. But what I love about this is like, this is not just like the function that calculates length. This is the definition of what the length of a list is. This is the length of a list. It is like, if it's empty, it's 0. If it's, you know, and I'm like, I don't know, that's cool.
That's so common, like handling lists that way. Head, tail, car codor from Lisp. You know, handling it that way is extremely popular with the functional programming languages.
Yeah, you know, so you just cool, man. How you doing, Sarah? Okay. I think it's time for all of us to get some lunch.
Yeah, I'm hungry. Really hungry.
I thought there was lunch included in these talks.
Right.
Sort of.
I'm
Just
not
ship
in
pizzas
charge
to
of the
everybody
brown
else.
bags, so you can have
It's a lunch bag.
Where's my lunch bag?
Lunch
Yeah.
bag. Where's the lunch bag?
gonna ask Brioche Healy over there. So yeah, so for Hacktoberfest, I am working on a Elm app. If anyone wants to like actually get into this.
Me.
Yeah, I knew it. I had this like book of like who I think will like really like this. I'm like, Sarah's definitely there.
I know. I legit went to ElmConf and didn't even know anything about Elm, and I sat in as many damn talks as I could, and I was just like, I need to do all this. Like, I like this, and I haven't done anything because life, you know.
Yeah, that's fine. Elm, that was the first time like I encountered like a really nice Slack community. They're actually like really friendly and super helpful. I didn't really mention that in the talk, but like,
What's that like?
They're nerdy. Apparently, Kirk and I have been in that community together and didn't know it. So you mentioned the other day that you were in the Elm Slack, and I was like, oh, I just took them off of my my desktop app because like I didn't contribute or anything. So
Yeah.
that's funny.
Since I joined this Slack, I've like been really shitty at all my other Slacks. Like I've been very neglectful.
So
I
This
feel
is the
bad.
best one.
Yeah, that's how we like it. So
Yeah. But no, I mean, honestly, and I think that's actually a key thing, right? Like it doesn't matter how nice your thing is, if new people don't have like a community to talk to, it just doesn't work.
Yeah.
Yep.
Right. So Elm, I think there's a couple people in the Slack that like they did eventually just like hire them. Like your job is to just help people, which I think was like a very smart idea.
That's smart. Yeah.
Yeah. So, I asked a lot of questions in there, and I still do because I still don't know anything. I was going to title this talk like, I can write a web app and you can too. Because like if I can do it, anybody can do it.
So you were talking earlier about how strict it is, like getting a return shape from a web call or whatever. I mean, does it at least do tolerant reader? Like if something extraneous shows up, it doesn't like puke, right?
No, so that's the thing. Elm will never puke. Oh, hold on. I think I have it. Okay, so like book, this is actually a perfect example. Ooh. So look at this init. So in this init, the model initial state is loading. There's an immediate command for the HTTP GET request, right? And URL is this, and it tells you like you have to tell what you expect back. HTTP expect string. You've got your message. The note here, when you get that result, you have to address, okay, what if the result was fine? And in functional programming, there's something called a result type. And result type basically is either like okay something or error something else. Usually the error is a string. So if it's okay, this is what we do, perfectly cool. But if it's an error, you also have to deal with that. Like you have to define what to deal with that. And then in the views, you have to handle all states of the model, right? So the success state, got it, the loading state, but also the failure state. And it won't, like if you always have to do that. Elm will tell you, like, you have to tell me what to do if this thing didn't work out the way you thought it would. So it's never gonna just like belch on you because you told it. Like,
well, that's okay between success and failure of the actual call, but I meant like more on the shape side. So if you had a book record, right, if you're getting a book, for the example, you have an ISBN and you have a title, right? And if the book service says, hey, we're going to start including a description, is that going to make my Elm app puke because a new field starts showing up?
No, well, Elm will not accept it, right? The shape has changed from what you said it is, so Elm will not accept it. But like it won't puke because once you tell Elm I'm going to take something from the outside world, it will tell you like, okay, so like what are we going to do when it works, and what are we going to do when it doesn't work? So that's already in place, but like it's not going to like try and take it in. I find like 90% of my problems right now with C# is that C# is always like trying to work with things when it really should just be not work. It should just like tell me, no, this is wrong. But it always like pretends like I can handle it. It's like, you can't. Speak up, C#. Talk to me.
It makes a very brittle contract between, like if I'm writing the book service and I have other users that do need that summary and I need to add that to my return, that's going to break your UI. That's very brittle. Right, I'd rather you just ignore the summary field. If you don't need it, just drop it and ignore it. That would be the better approach.
Well, I mean, I would say that is an alternative approach, and I get that, right? Like that's like the practicalities of the real world. Like that makes sense. But like Elm's goal is always that like I am okay, right? Like this is the homestead. Like this always remains okay. So you can say, like, as you said, like if it doesn't matter, it should be fine. But eventually, like maybe it might not. Like maybe they might have like it's so hard to be sure that like, okay, well, when they do make a change and it is a breaking change, right? Their API has changed, that it's going to be something that we can sort of like safely not even consider. But Elm sort of like takes a hard stance of like, I got to be sure, you know. And I mean, there's ways to shape like that JSON thing. Like you can tell it like, oh, well, some fields are optional. So it's not like it's everything has to be like this. But you know, that's but it is still very, that's one of the things I think a lot of people do sort of bristle about, especially JSON decoding, because they're like, I just want to take the JSON in, and then Elm's like, that's just not safe. And that's if that's like a hard sticking point for people, that's usually where it'd be like, okay, if you still want to be functional, there's like other alternatives, but like that is one of the sticking things for Elm. But you know, in the end, a lot of people are like, well, the thing is like my Elm app always works. Like the user will never see like oh, I don't know what to do. You know, it's always something that we've like handled. You know, so it's always, handle errors gracefully, always a graceful handle. So.
Yeah, I can see where it would, you know, it's very mathy in that way, and that's very refreshing. And I could see where even like an IDE, since it's so mathy and so structured, it could almost guide you through a refactoring, like where you change from card 1 to card 1 and card 2. It knows where things are going to break. It could almost guide you through that, like, oh, okay, here you're going to have 2 cards now. Start, you know, fix this dummy, and then it could almost step you through it. I mean, it does with the compiler errors, but I would imagine an IDE, since it's so structured, it could actually take you, hey, dummy, fix this here, go exactly where you need to be.
And I think, you know, that's the benefit, but like the trade-off for that is it does have to do like those things with like the JSON, right? Like it does have to say, for me to understand all of this has to be in a place where like there's no ambiguity. And whenever you're like, as long as you say, I'm just going to pass in some JavaScript, because JavaScript itself isn't forcing that same sort of security, like it could be anything, right? And even the existence of like none and nulls are things that can just completely demolish an API, because those are always like valid things to throw in, even though they're not like actually valid. Like any function in like Python that says I return an int can just return a null, or a none, and that's not an int, but it can just do it, and it doesn't have to warn you or anything. In functional programming, you have things like maybe types, where it's either just a value or nothing, or you have result types. Like, so that is, you know, I don't know. When I started, I really enjoyed I still like Python, but I was like, I like it because it's flexible. I like it because I can sort of like play around and fudge around, and PHP is similar. But as I've gone through time in programming, this type of explicitness, I realized like it is worth it, you know? And all that flexibility I thought was like super necessary.
I guess his battery finally died.
Yeah, I was just going to say we lost him. Well, that was cool.
All right, well, we'll get back at it later, I guess.
Yep, I will see you on Slack.
See you later.
Later.